So first, remember we're going to be, after we've solved all these equations, you're now going to be translating word problems into equations. And then the difficulty or the focus is going to be translating. Since we're so good at solving now, I think you guys' quizzes are really good. So solving is going to be the easy part, but translating we're going to focus on now. So let's look at some of the words that you might come across in addition to the ones on page 48. So equal to, it wasn't expressly written on there, but equal to means equals symbolically. You might also see is or altogether. Those are all equal signs. So you can write this in on on page 48, just put in the margin or something so you have it. These two are probably the most difficult. When do you use parentheses? Because when you're reading a word problem, right, it doesn't say, it says 1/3 of a number minus 2 times the sum of these two numbers. It doesn't say parentheses these two numbers or anything, right? It just says, leaves it out. So knowing where to put parentheses is going to be important. Okay. Twice, 2 times some number, right? Twice means multiplying. Half means to multiply. Some people didn't know, like when you take half of something, you're multiplying by a half, not dividing by a half. 2/3 of means multiply as well. 2/3 of a number, 2/3 of something. So these are a few things you'll see within the homework. Okay? Yep.
On half, it can also mean divided by 2, right?
Yes. So half of $10 is $5. $10 divided by 2. Really, you get this by multiplying the fractions together. So once you multiply a half times 10, you get 1 times 10, 10, then over 2. So yeah, multiplying by a half, taking half of something and dividing it by 2 are the same. Okay, here's a type of thing I want to show you that includes parentheses. Now, do you see the word parentheses anywhere in here? No. And if you guys know, probably if you're taking a foreign language especially, that if you take a sentence that's in a foreign language, something that does not work is that you cannot just take one word at a time and translate that one word and expect the sentence to actually be translated correctly. There's all these nuances about translating. So like here, we can't say twice, okay, some, okay, number, and 3 is 18. This is not correct. It does not work. You cannot do it, right? Just one thing, one number, right, at a time, right? It does not work. So this is why we're going over a few of these nuances. So when you see sum of, from right here, sum of, difference of, that's a signal of parentheses. We're talking about everything after that, sum of, that goes in parentheses. So that means we want to use twice the sum of a number and 3. Parentheses, a number plus 3 equals 18. So please be aware of that when to use parentheses. It won't say the word parentheses inside, okay, the sentence. Same thing here. We cannot just go 5 less 1/3 a number is, okay, 10. This is incorrect. What is wrong with this?
1/3.
Well, there's no sum of or difference of, so no parentheses here. However, if it's confusing like this way and the variable and the fraction are throwing you off, what happens if you did this with just like 20? What is 5 less than 20?
15.
And how'd you get 15? 20 minus 5, right? Not 5 minus 20. So it's the same thing even though it's an expression. The correct way would be 1/3 and minus 5. In English language, we might say, oh, I want 5 less than this. But how you calculate it is really you start with what's bigger and then you remove 5. You take off 5. So again, we cannot do just a straight take a word, translate it, take a word, translate it. Just like any foreign language, it does not work. Okay, you have to understand what the content of the sentence is really trying to say. And you notice when I said, okay, what's 5 less than 20, everybody knew what order to go. Oh, that's 20 minus 5. A lot easier to use real numbers, not just all algebra and all abstract stuff. Okay, real numbers do work easier. Okay, so now, just to give you those two things, what I want to do is get you started on your homework. So we're going to skip all the way to 62. So you're going to do like 1 through 16, except for one of them, and I'll tell you which one not to do. Make sure you read the directions, and make sure you answer, the question when they ask it. Okay? Exactly. So it says here to write an equation. It doesn't say solve it. It says to write it. So make sure you just write it. So again, we can't just say, okay, sum means add, of means multiply, 14, and means add, a number. Like, see, this doesn't even make any sense, right? Plus times 14 plus n is, so we have to understand what they're saying as a whole sentence. The sum of 14 in a number is 17, right? So they're talking about adding two things up, some number you don't know, and then 14. So we have 14 plus n equals 7. Okay. On number 2, they said instead of sum, they say increase by. Okay, same thing. And on number 3, they say difference. So that's subtract.
How we write number 5?
Sure.
2/3 times n.
That's what we said in the beginning of the lesson. Write it down. Okay. Just follow the notes.
We don't follow it?
Does it say to solve it?
No.
Okay. So you're good. Just follow directions, you'll be good. We already went over what 2/3 of a number means, so you wrote that down hopefully from the previous slide. If not, you can watch the video and see how to do it. So next part, after we get past the basic one sentence easy ones, although I don't, for some reason this is not capitalized. Okay. Tenmaya wants to raise $175 for a school fundraiser. She has raised $120 so far. How much does she need to reach her goal? So what's one equation you can use to solve this?
n plus 120 equals 135.
Okay, good. Does anybody have another one? Something else? How would you solve this equation?
You would subtract 120 from 175.
Yeah, so somebody else might come up with this. Oh, the answer is going to be this. It's 175 minus 20, and that equals n. So you can have either equation, and they both give you the same thing. It just depends how you think. Some people think, okay, what do I need plus 120 to get 175? Other people will just go, okay, just subtract 175 minus 120, and that gives me the answer, n. Notice how these are both correct because they're both equations, and they both have variables. The second one here is actually the first step. If you solve this and subtract 120 on both sides, that's what the second equation is, but that's fine. Okay? So number 7 is very similar to number 6. Instead of money raised, it's miles driven. So it's very similar. Okay? Next, we're going to look at perimeter. Okay? Perimeter of a rectangle. So a good idea. Draw a picture. We know that the shorter side is usually called the width. The longer side is usually called the length. Use a cursive L when doing length, not a 1 or an L that looks like a 1. Use a cursive L. What does perimeter mean? Hold on. That's the distance all the way around. Like you're counting how many feet it was to walk around a park or something like that. So, but in this case it says the length, instead of using length, you're going to say the length is twice the width. So this length is the same as 2W. So use an L, use 2W. Of course, opposite will be the same because it's rectangle, and the width will be the same because it's rectangle. Now we know, add those all up, it will equal 126, and solve. Well, actually, no, not solve, because this page that says the right page.
Number 5.
That's the same as we did on the first slide, 2/3. Now, number 9, that's the one I want you to skip. We'll go over that together a little later. Okay? Number 10, very similar to number 8. Look at number 8, another perimeter problem. Yep. Now, what is the answer in number 10, though? What are they looking for? The length and the width. So this is asking you to actually see write and solve. So starting here, your answer when you solve the equation is going to be L equals something, right? But don't stop, because they want to know what L is, but they also want to know what the width is. So make sure you don't just say I solved the equation, the L, length equals 7. They want to know what the width is as well. And the width is just 4 less than the length, so it's not too much harder. Not too bad, not too bad. Okay, 11, there'll be some other perimeter problems as well. You've seen these types before. Sometimes we're talking about ages, sometimes we're talking about how many hours did you work, but they're all done in the same way. They usually involve 3 people. So if you read this at first, Ruby worked 6 more hours than Isaac. Svetlana worked 5 times as many hours as Ruby. Together they worked 126 hours. Okay, first thing, how many people are there? 3. So start off with something simple, like Isaac plus Ruby plus Svetlana. They all add up to 126 hours. Start off with something simple. Try not to go, okay, one of these is going to be 6 plus R because of 6 more than that, Just start off with something simple, and let's just find out, can we write all these people's hours worked using one variable? Okay, so for instance here, Ruby worked 6 more than Isaac, right? So we can go back to here, instead of having R, we can use 6 plus I. Okay, Isaac is still Isaac. Ruby is now 6 more than Isaac. Okay, so I just took out it's called substitution. I took out Ruby's hours, and I said, well, Ruby's hours is the same as 6 more than Isaac's hours. So now we can see we have Isaac's hours, I. We have Ruby's hours in terms of how much Isaac worked. So we can see we want to write everything in terms of Isaac. And then we go, let's see here. Then Lana worked 4 times. So Lana worked 4 times Ruby. Right? 4 times whatever Ruby worked. Well, we already know that Ruby worked this much, right? So Svetlana worked 4 times 6 plus I. So again, see how we wrote Ruby using I? And now we have Svetlana, only I, in terms of Isaac. Now it's something that we can solve. We only have one variable. So it's really difficult to read this and go straight to this thing right here. Really have to start off here and say, once I knew that Ruby was 6 more hours than Isaac, I can really see, I want everything to be, using Isaac's hours work. And then this one, yes, go through and solve. Now, what is the answer to this? Okay, at the very end, it's I. What does I stand for? Isaac. Is that it? Is that the final answer? No, right? Because they want to know, find the number of hours each person works. So as soon as you get I from the equation, don't stop and say I'm done. You need to figure out how much did Ruby work? And then Ruby, you know, is 6 more. And then you have to figure out, well, how much did Stanana work? Well, that's 4 times whatever Ruby worked. And so don't stop just because you solved an equation. That's what the biggest difference is from what we've just been doing. Once you solve the equation from last night's homework, you're done. Okay, the answer's down at the bottom, you're done. But here, you're not done when you solve the equation. And even at the end, it'd be great to say, Isaac is this many years old. Isaac worked this many hours, Ruby worked this many hours, Banana worked this many hours. Actually write it out. Okay? Show that you completed and written all the information. Okay? Yeah. Maybe one. Let's use all of them actually, but start again. You have to find out how much Isaac worked. Once you know how much Isaac worked, then you can find out the others using these right here. Let's see here. Do one more, same thing. And one day, Annie traveled 5 times the sum, there it is, parentheses, the sum. And together they traveled 20 hours. How many people are there? Are there? 2, and it is Annie plus Brian. And we know the miles total add up to 20. So we just need to have something for Annie, something for Brian. Alright? So it's good to start with something basic. At least I know I'm adding up 2 things, 2 people's miles. I just need to have an expression for each one. And figure out what they are. So Annie traveled 5 times the sum of the number. Okay. So 5 times the sum of a number, I'll say n plus 2. Now, is this, I'll use H actually for hours. Is this Brian's mileage or Annie's mileage? That's Annie. So how much did Brian go? See, this is why it's good to define the variable at the very beginning. Notice how when we use our variable right here was the hours that Brian actually traveled. So Brian's mileage was just H. Annie's was, H plus 2 times 5. That equals 1. Going down, here it's going to change just a little bit. You're going to be comparing 2 situations. When you're comparing 2 situations, that's a good hint that you're going to have an equals. You're going to have an expression on the left, an expression on the right, variables on both sides. So here it says, okay, you're going to buy a motorcycle for some reason, I don't know why. But at one dealer, you pay $2,500 down. That's how much cash you have to give them up front, and then how much you have to give them per month. And somebody else is saying, okay, $3,000 up front, and then $125. So this one is less money up front, more per month. This one is more money up front and less per month. They want to know, well, how long it takes till they're actually paying the same. So we got $2,500 plus $150 every month, per month, times that. When is this equal to $3,000 down plus only $125 per month? So you can see it turns into an equation just like we've been practicing on the worksheet. If you get some equation and it looks really weird, like I don't even know how to begin solving that, and you did your homework, thumbs up. Because it should turn into something you can practice for. All that we just did on a worksheet for practice. So when we translate these, we'll know how to solve them. All we can translate it correctly, we have already practiced many times over, and put the quiz on how to solve it. This one is the same exact thing as the motorcycle one. Instead of down payment, it's $50 membership fee, and then it says monthly payment is the monthly fee. So look at number 14 here. Same thing here. $200 down payment, $10 every month. So this is the same as 14. So I don't want you to look at all these and say, okay, I got the 15, how do I do this one? I want you to see that 14, 15, 16 are basically all the same. If you see the similarity between them, it all has some money up front and some money per month. That's all you need to know. All right, have a good weekend. 1 through 16, write it down. 1 through 16, skip 9.